Hi guys! Time to do an example of the electric force, which of course is the force between anything that has charge. So I'm going to do two examples here that are kind of fun, and let's do them. So example number one, let's plug in some numbers. So the first is, let's say we have an electron and another electron, and they are 1 meter apart. What is the force between them? Well, of course, the force will be directed to the left for this guy and to the right for that guy. And the value will be K, Q over R squared, which would be K times E over 1 squared. So it will be K times E squared. If you recall, E is the elementary charge, you might be tempted, be careful, you might be tempted to think that E stands for electron. And while it's true that the electron has the elementary charge, don't forget that this is also the charge of the proton. And negative E is the charge of the electron. So remember, we're not plugging in negative signs into this equation. Technically, we're taking the absolute value of these. Right? And it wouldn't have mattered anyway because the negatives would have canceled out. But remember, this is just the number, Ke squared. So the elementary charge is the charge of a proton and of an electron, where it's positive for the proton and negative for the electron. Of course, this value is 1.6 times 10 to the negative 19 coulombs. And if we plug that in here, we can get an actual value for the force. 9 times 10 to the 9, 1.6 times 10 to the negative 19 squared, and you get some value which I don't really want to do on my calculator. Cool? Hope that makes sense. So review of what the elementary charge is, that it's the charge of a proton and charge of an electron equals some number. So here's the question. If I have two protons, is there anything different between this example and this example? I hope you see it. The answer is absolutely no difference in the force between two protons and the force between two electrons. We're also going to get K times E over, of course I forgot to put in the distance, if they're separated by 1 meter, we'll plug in 1 squared and we get K times E squared. Same exact number. Isn't that cool? So if the charge is the same and the distance is the same, the force is exactly the same. So what would be different? Well, of course, the difference between a proton and an electron is mass. So the mass of an electron is much less than the mass of a proton. So for the electron, when we set this equal to, what are we going to set it equal to, guys? Force equals mass times acceleration. So the force is given by this number, and we set it equal to the mass of the electron times the acceleration. And if we set ke squared equal to the mass of a proton times the acceleration, sorry, that's a subscript. I'll make that more of a subscript. And I'll erase this negative sign there. That's oops. Then, of course, what's going to be the final difference? The difference is that the mass of the electron is much smaller, so its acceleration is much larger. So they're the same force. The mass of a proton is much heavier, so they're the same force, but of course the mass determines that the electron would move much faster than the proton. Or these two electrons, which have the same force, so this is on just a single electron. So notice I'm not plugging in a 2 here, because I'm only looking at one electron at a time. So on this electron, this one will move to the right at an acceleration equal to this divided by m, and the proton would move to the right at the same force divided by m proton. Of course, this electron will move much faster than this proton. And this electron will move at the same acceleration as this one, only to the left. And this proton much slower to the left also. So these guys will go apart much slower than these guys will go. Same force, because why? Same charge, same distance. The difference is only when you calculate the actual acceleration. I think that's a cool example. Example number 2 will be in the next video.